This is a quick review, C++ string. We already talked about this, but let me just kind of go through some of the highlights. C++ strings, array bound checking not available. Okay, so sometimes when we're talking about array, we're talking about strings too. So, and this is a very important fact. Array bound checking, however, in other languages like Java and C++, they are available, right? So as you can see, and we talked about this is, let's say if you have a memory cloud, this is the entire memory space at runtime. And what is sitting inside of this is a whole bunch of ones and zeros, right? And represented by bits. Let's just say that a small portion of it is occupied by your arrays here. Now, when you execute, right, or manipulate data in and out of this array, C++ doesn't give you the facility to say, hey, you are still working within the constraint of this array. You could be working outside of it, right? But remember, whenever you go outside of your available or allocated area, you are stepping into someone else's memory, right? So this could be someone else's memory here, right? Used by, right, some Windows processors, right? Let's say your machine is running on all kinds of stuff, right? So Windows browser, right? Whatever that is. And so whenever you step in, right, into this area at runtime, and this part is being used by someone else's, right? As you know, C++ allows you to kind of step into a specific portion of the memory. You get a pretty nasty crash, right? Sometimes an error coming back out and percolate it all the way up through your program and resulting in exceptions, okay? So these are errors, right? Sometimes it could be as bad as a crash, right? Program crash. So this is what I want you to understand, especially, when you were talking about C++ strings, you're manipulating an array of characters, right? And if you're not careful, you can step outside of the boundary leading to errors. Now, this is not the case with Java. In Java, there's array index out of bound. And the other thing is array in Java, ARRAY, is an object, okay? Which means there's a class representing array as an object. Every time you instantiate an array is an object. So an object is a class, right? And a class has a whole bunch of facilities and error checking and all that stuff. C# as well, right? So treating these arrays as objects. So you can effectively leverage the array's native properties and behaviors to perform bound checking, meaning like if you're outside of the bound, they'll give you this error, right? And this is true in Java, not C++, not C#. C# has a different exceptions. So you get the idea. C++ is almost like a driving a manual stick shift. And Java, C#, you can maybe think about driving, cruising on an automatic card. So you don't have to worry too much about it, but you still have to provision, right? In case when the error exceptions happens, you have to capture them. But C++, you're completely on your own. So that's one thing I wanted to mention. This is very important aspect of C++. This also makes C++ a lot faster than some of the other languages like Java, C#, because C++, they're closer to machine, right? There's not a lot of these interactions and checking or validations at runtime, making it an ideal for a lot of lower level, applications such as drivers, such as some of the firmwares that you see on the market today. Okay, so let's move on to the next one. Let's talk about C++ string now. Now, this is something that we went through. C string looks a lot like C++ string to some extent, right? So you see the value here, but now when C string is used in the context of this fashions, right? And now this CEDU, even though it's double quoted, this is a C string, okay? And it looks a lot like the C++ string. And the difference is how you basically declare the string, right? So the declarations here says that this is an array of charts. Even though you don't specify the number of characters you have in there, it is inferred, right, from the right side, this right-hand side, that you have 3 characters plus 1, the very last one is 0. So if you expand this edu into array, there's actually 4 slots here. Okay, the first one is E, right? This is a character, so it's a single quote. The second one is D, right? The third one is U, and the fourth one is the null terminator or 0. Okay, so there's actually an invisible null terminator at the end, making the size of your test string in C style string to be of 4 bytes, right? Each character is 1 byte, so there's a total of 4, and this is null terminated. Now this C++ string is a little different. C++ string is a class, okay? So at runtime, this C++ carries a whole bunch of native methods and behaviors. So you can go into your API and look at the string available strings function or methods, right? So size, right, or length, right? These are available methods and you can leverage in string when you instantiate it, C++ string. Since this is a class, this entire class, the size of the class is a lot more bloated than just 4 byte C, right? In fact, if you do a size of, right? By the way, size of is a function, is a standard function in C. And you can, let's just say this is string, right? Or in this case, test string, size of test string. In a lot of computers, you'll probably see 24. So this is roughly true in 64-bit computers today, that the size of string it's 24 bytes, which is a lot bigger, right, than the 4 bytes. So as you can see, you can fit a lot of characters inside of 24 bytes. Inside of the C++ string, there's also a buffer that's similar to the C buffer here. That stores these characters, but along with the buffer itself, there's also other methods inside the C++ class, making it 24 bytes. So these are the two differences. Whenever you see C string, you count a number of characters plus 1. Okay, that would be the total size of that string. And obviously, if you do length, length of your C string is 3, but the size of a C string is 4. Okay, so that's the difference. Okay, so that is your C++ string in the upshot. Let's move on to the next review topic. So next one up is C string library usage. So as I said, there are many standard libraries are available in C. As you know, C is, or C++ rather, is a subset of C, right? So every time you apply these libraries to a C++ program, your C++ program will compile, right? Because C++ backward compatible since it is a subset of C. So you can apply these C style string standard libraries to your C++ program as well. A lot of times people, they make use of both, right? It's just, by nature of how C++ are related to each other. So you can utilize methods such as these are actually functions in our method because this is standalone standard libraries in C, and they are part of the C string. So in either you do C string or you can do string.h. Okay, so this is an old way of writing C string, right? Before C++ came about, C string is the string, so they use string.h. But if you do string, this is actually for C++ string. So you don't want to do that. If you want to include size of and string length, you want to do C string or string.h. Some of the IDEs, they automatically include them, so you don't have to pound include again. So at runtime, you would have these functionalities at your disposal. But just remember that there's probably several dozen of these. There's also string comparison functions that you can use, or string stir, find, or stir and stir, right? So there's several of them that you can make use of to manipulate string. And these string must be a C string, right? Not C++ string. So whenever you're dealing with these functions, you have to make sure that what's included inside of it is a C string, okay? All right, so there's a question, what is the difference between size and length of a C string? In fact, we already talked about this, right? The size of it is a total number of bytes, right? So this is number of bytes, right? As you know, C string has a null terminator, so you would simply count the number, right? The length of a C. So you can say size equals, right, length plus 1. Okay, so that's the relations between the two. So this is a quick review of C++ string library usage. With respect to C++ style string, you have to include string, right? So we talked about this. You don't want to use string.h or C string, right? So they're different, right? With respect to C++ style string, let's just put them through this C functions as well and see what happens. So the size of a test string, right? So this doesn't have to be a C string. This could be a C++ string because the size of simply counts the number of bytes. So on most machines, 24. Start length, right? The number of characters inside the test string. Now, this is an error because test string is a C++ string, so start length applies to only C string only, right? And when you count the number of characters you have in a C++ string, you dot it, okay? So this means that this length, right, is actually a method, okay? They're not function. There's actually a difference. So this is a function, right? Function is standalone. Method is a part of a class, right? So test string is a C++ string class. And so in order to invoke its method, you have to do the instance of this C++ string dot, right? Using this dot operator, dot, to invoke its method. We'll talk about later on, this dot can become an arrow if this instance itself is a pointer, but now we're talking about a static object here. So in order to test or ascertain its length, you would do a dot length and then you get 3, right? So this means that the total number of characters you have in this C++ string is 3. Okay, so string is a class, is a function. Actually, this function has to be, is supposed to be method, not functions, right? And operations. They're invoked on a class via dot. So we talked about this. Okay, let's move on to the very last topic. So a stream class is in C++ is a stream class, right? To operate on stream. So you can think of this entire stream class, right? It's a buffer, right? It's kind of like a faucet. When you open the faucet, right, water comes out, right, or liquid comes out. You can think of these stream as that, right? Like a physical stream of water or something. And the way that how this works is this stream buffer, which is the source of water, right, contains a sequence of characters. So the way that you would concatenate or attach these characters into the stream is by using these operators. So there's a less than sign. This means reading from. There's also writing to, which is the greater than signs, right? So the way how I see this is the information flow, right? So this less than sign means that the information is going from right to left, right? And this sounds like it's going from left to right, right to right. And this is right to left. This is how I kind of memorialize it, right? In the future, when you don't remember, just look at the arrows where this thing is going. So this means that 1, 2, 3, right? So first of all, you instantiate this on the stack, right? So there are 3 variables here, instances rather. 2 C++ string instances, S1, S2, plus 1 instance of SS string. So if you do SS, right? So 1, 2, 3, this means that 1, 2, 3 itself, which is an integer, right, is now being concatenated into SS. So SS initially has nothing in it, right? It's empty. Okay, so now by way of streaming 1, 2, 3 into it, you have 1, 2, and 3 in it. Okay, and then there's a whole bunch of space, right? The space right in between, plus 4, 5, 6 are also going in. So you have 4, 5, 6. Okay, so at the end of this execution right here, what you see here is this 1, 2, 3, whole bunch of space, 4, 5, 6, right? So this is your SS buffer. Now, what's happening is you're spitting your information back out, right, from this well of water or liquid that has these characters in it, or buffer. The first thing is that you're streaming the initial portion, right, which is this portion of your string, right? It's almost like a queue, right? The first thing that goes in is the first one that comes out. So the first one that comes out of it, when you using this S1 to capture it, is 1, 2, 3, right? So what you ended up with S1 is going to be 1, 2, 3. And then what happens is, because this space has a whole bunch of zeros in it, it'll actually tokenize the entire string 1, 2, 3 by the space, okay, or spaces. The second time that you try to stream this thing into a buffer S2, this will give you 4, 5, 6. Okay, so this is curious because now it eliminates all of the white spaces in between. And so that's the nature of string. It doesn't care about these white spaces or empty spaces in there. It'll simply bypass them and look at just the characters, right? So these 1, 2, 3 could be X, Y, Z, right? Could be the actual characters itself. Doesn't have to be integers. So that's how we use string because it's very easy to insert textual information into the string and the output itself. A lot of it is from comma delimited strings resources. So not comma delimited, but or space delimited rather. String source. So this is how we use string streams. There's a lot of use cases out there. You can take a look at the c++.com articles that talks about these things in more detail. So this completes our review of C++ and C string.